Hello and welcome to another episode of Solving Exact Differential Equations. Here we have problems from the book Elementary Differential Equations, 8th edition by Earl, Rainville, and Phillip and Richard Bedient. These problems are from page 34, exercises 2.4, and from number 13 and 27 respectively. Let's begin by solving the number 13 problem, which is y squared minus 2xy plus 6x dx minus x squared minus 2xy plus 2dy is equals to 0. So to solve for exact DE, first we must test its exactness or test for exactness. By doing so, we're going to do this. First, we need to solve for this one by using this equation and deriving this with respect to y. So, and let's solve this using this equation and deriving this one in terms of x or with respect to x. So as you can see, both sides are equal. So this is an exact equation. And when it's exact, we can now proceed to the next step. Our m here will be this one. We're going to use this as a substitute for our m. So let's have now let's integrate both sides by dx. Since y squared is constant, let's move that out, as well as negative 2y and 6. The integration of dx is simply x. The integration of x by using the power rule is x squared over 2. In this equation, instead of using the arbitrary constant, which is c, we'll be using an unknown function. Let's say, for example, g of y. This can be further simplified, so let's simplify this. Now, let's proceed to the next step, which is the derivative of this function with respect to y equal to n. Our n here will be this one. So we'll have the derivative of our function in terms of y. The derivative of xy squared is simply 2xy. Derivative of x squared y is x squared only. The derivative of 3x squared is 0, so it's okay if we don't write it down. And the derivative of g of y is simply g prime of y, then equal to our n, which is negative x squared plus 2xy minus 2. As you can see, there are terms that can be cancelled out, so let's cancel it. We have the positive 2xy and the negative x squared. So all that is left is g prime of y is equal to negative 2. To get the g of y only, we need to integrate both sides by dy. Since negative 2 is constant, that will be moved out. So our g of y now will be negative 2y plus c. So let's copy our function since we'll be using this equation. Let's copy our potential function, which is xy squared minus x squared y plus 3x squared. Since we have found the value of g of y, let's put it here or substitute it into the g of y. So negative 2y plus c or equal to c. Now this is our answer. Let's proceed to the next problem. Here we have the problem 27, which is 2x times 3x plus y minus y e raised to negative x squared dx plus x squared plus 3y squared plus e raised to negative x squared dy is equals to 0. First, let's distribute this 2x inside this parenthesis. So we have 6x squared plus 2xy minus 2xy e raised to negative x squared dx. Then copy. Now let's test for the exactness. We need the value of this one equal to the value of this one. As usual, we'll be using this to solve this one. With respect to y, we're just going to derive this equation. Now we'll have the derivative of 6x squared is simply 0. Derivative of 2xy is 2x, and the derivative of 2xy e raised to negative x squared is negative 2x e raised to negative x squared is equal to, we'll be using this one to solve this and deriving this with respect to x. Derivative of x squared is simply 2x, 3y squared is 0, and the derivative of e raised to negative x squared is negative 2x e raised to negative x squared. So when you see expressions like this, the derivative of this one will be the derivative of its exponent. So the derivative of negative x squared is simply negative 2x. Then copy e, then the exponent. Okay? Since this is exact, we can now proceed to the next step. Let's have terms of y is equal to our m, and our m is this one. So we'll have 6x squared plus 2xy minus 2xy e raised to x squared dx. Now let's integrate both sides by dx. 6 is constant, so that will be moved out. as well as 2y derivative of x squared is x cubed using the power rule. In this one, we're going to use the u substitution. So let's let u is equal to e raised to negative x squared. Du is negative 2x e raised to x squared dx. And let's rearrange this so we can get this one since it's the same or they look the same. So we're just going to write this one here. And I will have 2y negative du or 1/2 du. Now let's simplify. Since negative 1/2 is a constant, we'll move that out, so this negative will become positive. Then the derivative of du is simply u, then we'll use an unknown function g of y. Then let's return the value of u. And that's our potential function. Now let's solve for the g of y by using this equation. Deriving the function or the potential function with respect to y equals to n. Our n here will be this one. So the derivative of 2x cubed is simply 0. Derivative of x squared y is x squared. Derivative of y raised to negative x squared is e raised to negative x squared only. And the derivative of g of y is g prime of y is equals to our n, which is x squared plus 3y squared plus e raised to x squared. Since this can be cancelled out, let's cancel this out. So all that is left is g prime of y is equal to 3y squared. So integrate both sides with dy to get the g of y only. So we're gonna have 3y cubed over 3 plus c. Simply gy is equal to y cubed plus c. So to get the final answer, or our f is equal to c, copy our function, which is 2x cubed plus x squared y plus y e raised to negative x squared. So our g of y now will be y cubed plus c. So plus y cubed plus c or equal to c. And that's our final answer. So that's it, guys. I hope you learned something, and also please subscribe to our channel and help us or support us by watching our other videos, and liking them. That's all. Thank you.